Hello and welcome to this SlimDevOps episode 53. I'm back with Primoz. How you doing, Primoz?
Hello, I'm doing fine.
Excellent. Oh boy, howdy. Is this going to be an interesting one? Let's see how we get on. So, if you're watching this on YouTube after the fact, this was originally streamed on twitch.tv/SlimDevOps on, what is it today? The 3rd of August. What we're about to have a go at today is a few weeks ago we had a couple of streams where we made a highly optimized operating system for the Raspberry Pi, specifically for running and building containers. And that's great and everything, but we want some containers to run on it. And I was thinking, well, we could just go and grab any old containers, but how about we try and apply some of the same optimizations we used for our host operating system to base images. So we're going to try and make these base images as small and tiny as possible. I think it's probably best if we sort of start at the beginning and just go back and look at what we did before, because there are images that all of you can download for your Raspberry Pis if you have them. So if I push that button there, here we go. So I will post this link in the chat. And the reason Primoz is back is because Primoz was keeping me honest during the last couple of streams when we cooked up our base images and was helping me make some of the decisions about like how why can't I highlight that? There we go. So I'll put this in the chat here. This is in my own repository, but we'll probably move this over to the SlimDevOps account in due course. So we'll just remind ourselves what's in here. We had this script here. And this does a whole bunch of manipulations with essentially, let's start here, using Devbootstrap in order to create a very tight, minimal Ubuntu-based operating system. And although this is based on Ubuntu, we absolutely cannot call it Ubuntu because we changed a whole bunch of expected behaviors. So we use this script to build, and we're going to return to Devbootstrap again today. And we were building this image on an x86 PC. And we were using this little wrapper here to actually use systemd container managers to manipulate these ARM containers on our Intel PC in order to create a host operating system for the Raspberry Pi. And we got quite a long way with this, I seem to remember, Big Pod. We were... I think our landmark accomplishment was the 32-bit ARM version was running with Docker everything enabled in 91 megabytes of RAM.
Yeah.
Does that sound about right?
It was pretty small.
Yeah, we did well. So let's just take a look at this here. So anyone that wants these are available to download, or you can, run the scripts. And I see there's a pull request, and I suspect that might be from Takov. So in the releases here, we have this pre-release. We have today's build that we've uploaded, and in the assets here, you will find the images for 64-bit ARM and 32-bit ARM and the corresponding hashes for each of those, so you can verify the download. So these compressed images are 553 megabytes. Remember, these are operating systems that go on the Raspberry Pi. These are not container images, and this is a very, very small Ubuntu-based OS that also has the Docker engine integrated and enabled. And if you want to run these on your Raspberry Pi, I've rather helpfully explained which Raspberry Pi models this will work on, and also how to stick these on an SD card or a USB stick using the Raspberry Pi Imager. So I have installed this on my little Raspberry Pi dev machine, this exact build. So if I SSH into here, here we go. This is our our very small. I'm just going to bump the font size up on this a little bit. Maybe that was a little bit small. Hopefully that's a bit more visible. So let's just do, how can we prove what we're running here? Uname -a. There we go. So you can see here, we're running the Raspberry Pi kernel. We're running SlimEOS, as we called it, Slim.AI OS. And this is the 64-bit ARM version. And if we just do a process trace on everything that's running at the moment, you can see it's pretty tight. It's basically systemd and then network D dispatcher. Yes, we did need to have that. Then syslog services, and then here is containerd from Docker. We're using dropbear for the SSH to do two things: minimize the amount of file system space that OpenSSH takes up, and also the amount of memory that it uses, and then policy kit. So this was it, and I don't know how much this is running in, but not very much, I don't think. This is using 145 megabytes, and this is the 64-bit version. So, you know, this was pretty good. I'm very happy with this little operating system. It's not bad.
Yeah.
And if we do Docker images, you know, it's all there ready to be used. So here is an OS that you can play with, and I know Takov's been showing some interest, so let's just take a quick look and see if Takov has, in fact, he is talking about supplying a pull request to, oh, this is Phil. Hello, Phil. Thank you. What have we done here? A couple of those hard to see oopsies. Thank you. Right then, am I logged in? Yes, I am. Okay. So let's see what embarrassments has Phil. So Phil's just basically sorted. Oh, thank you. Well done. Yeah, I borrowed some documentation from another project, or bits of documentation for another project. So that will get merged. We will merge that one. Thanks very much, Phil. I appreciate that. So anyone that wants to follow along can follow along. But what we're going to be doing initially now is we're going to have a go at doing something similar, which is using a PC to build ARM64 and ARMHF base images. So this time, because the interesting thing about these images is that 500 megabytes, that 500 megabytes, the overwhelming majority of this file size is actually the Linux firmware package, which is about 50% of the OS image is just firmware blobs. So you know, we don't have any kernels or things like that to deal with in container images, so it'll be interesting to see how much time we can how much smaller we can get them. So, hey, the dumbest idiot. Whose hair are you referring to? Mine or Big Pod's?
I think it's referring to my hair.
Yeah, you're looking very tidy. I need to get myself down the barbers. Hey, Musical Coder, welcome back. How you doing? Right then, so let's hop over. So now we did something similar to this a little while ago. So this is the script that builds the host operating system with a few, you know, improvements we could still make. And I don't know, when did we do this? I think about 4 or 5 months ago we did a stream in response to Kelsey Hightower's Always From Scratch, where we created a from scratch Ubuntu base image. So what I did is I dusted off the code from that exercise, but that was an Intel base image, and we really didn't care too much about the size of things. So I've dusted that off and I've wrapped it up here, and this is what we've got. So I thought I'd start by explaining what this does, and then we'll get into cleaning this up so it's fit for purpose for what we want to do today. And then I suppose the thing we need to do is like generate an initial root file system, which is what this will do, and then generate a base image. But then we need to see, have we actually like got something smaller than Ubuntu? So that could be tricky, because there's a whole team of people whose job it is to prepare these container images. And also, we're going to be ruthless. We are going to eject everything we can that is absolutely not required in these container images, if at all possible.
Password D.
Well, yeah, I mean, well, actually, that comes as part of another package which we do need. So we'll be as ruthless as possible. We'll see what we can do. So the first thing is we've got this here, which was make sure we're running as root, which I don't think we need. So I'm going to probably get rid of that. We've got some variables here. This, again, we're going to refer to as an alpha 1 image. It's based on Ubuntu 22.04. And as you can see here, the initial architecture we're going to try and build for is ARM64. And that's because that's the version I have installed on the Raspberry Pi here. And then this base stamp is our version for the day, effectively. So this tells us to generate a version number, which is the year, so 22, and the day of the year. So you get a new version every day, which seems granular enough for the purposes of this exercise. I just have a general build things in this directory in my computer. So that's why that directory is set. And then we're going to reuse a package cache. That it's fine if this doesn't exist, but in my case, because I've built those host operating systems, I have some of the packages cached locally. Just saves some time. And then this is where the root file system is actually going to get composed. So we set those up, create some directories, and we define a variable for the tarball. The tarball is going to be the root tarball of the root file system that we'll use for our Docker file. Something that I do in projects of this nature is to use aptcache. That's just to save me keep on downloading the same packages via the internet all the time. This will cache things locally in a proxy, so it saves me a bunch of bandwidth and what have you, and time on these streams. Then here's our Devbootstrap, which looks very similar to, well, it looks similar to the other one, but not as sophisticated. The only thing here is this is from when we did this before. We used the min base variant, which basically instructs the bootstrapping process to provision just the required packages, the packages that are marked in Debian as required for an operating system to run. Now, when we did our image, our host operating system image, we actually spent some time tuning that. So while we didn't use the min base variant, what we did do is we got into this business here where we excluded and included a bunch of stuff. So we'll try and reuse some of that here to keep the size of things down. Then we clean up the package cache. We if there is an existing tarball, we'll attempt to delete it. Let's just make sure that that silences any standard error. Then we compress that file system into a tarball, and then we set the permissions on that tarball, so it's just readable by everybody and read-write by the root user. So that's the script, but I think I'm just going to get rid of this bit. I don't think Devbootstrap needs to be operated by root. So all of these directories that I'm making are in the context of my home directory. So I've just changed that. So I think there's nothing here now that should require a root user, because that's deleting things. That might. Okay, so that might throw an error, but okay, we can, oops, I've got an error here as well, look. Okay, so I think that's going to work. Let's think. This is a root file system. Yeah, this is not going to work. So we'll have to... Okay, I'm just going to back out those changes. We'll leave the root bit in for now, because we may want to do more operations inside this file system. Yeah. Okay, let's check. I think that'll do it. Well, let's see what that does. I think that will do something useful. So if we come over here, we'll leave the virtual machine. The virtual machine is not virtual machine. Leave the Raspberry Pi, and we'll run that script as me. So what Devbootstrap does is enumerate those required packages. It downloads them, which it's doing now, and then it extracts them into a directory which you can use as your root file system. So this is a very convenient way to create virtual machines or container images or all manner of projects. You can sort of provision a base operating system which has got just enough stuff to sort of build out the rest of the thing. And once you've got that base, you can then step inside that. In the old days, it would have been with CH roots and things of that nature, but you can step inside it with a number of the container technologies and virtual machine technologies, and then run additional components to, you know, build an operating system. Now, as it happens, because we're going ultra small here, we don't need to run anything else than Devbootstrap. So that has completed. And in the builds directory, here we go. So we have a 32 megabyte tarball. So what we probably want to do is take a look at how big the root file system is uncompressed as our starting point. So I just need to remind myself we're building ARM64 here, and we're building Slim.AI, and we're building no hang on a minute, I've lost where I'm building this. Hang on a minute, I've lost the root file system. Where did we say that should be? 0 base release, which is 0 jammy.
Well,
okay. Go on, what were you going to say?
I was going to say, look a bit up what base release is.
It should... Oh. Yeah, oopsie. I keep... Base release is jammy. So that should be the temp directory architecture SlimDevOps base version 2204 base release. Root FS. We definitely make the root file system there. Why am I not seeing it? Root. Well, we clearly did have a root file system because we've made a thing. I've lost my build environment. Where did it go? Ah, here we go. Have I got a bug in my... Yes, I do. I have a bug here. There we go. I've got a bug in my variables. There's the file system. Okay, right then. let's try this now. I see Primoz has had to disappear, so hopefully he'll be back. Right, so 87 megabytes. In fact, let's get that a little bit more. Hello, welcome back.
It seems I have a bug in my scheduling.
Okay. Have you got to hop onto something else?
No, I forgot to tell the family that I am not around, and therefore I was called for a tech support issue.
I see.
As always.
I tell you, it's great that your family runs so many containers and that you're able to help them out. Right then.
No, it's not containers. It's the TV is broken.
Oh my goodness.
The fix, turn it off and on.
Yeah. It's just like cars. Stop the car, get out of the car, get back in the car, start the car. That usually fixes it. Okay, so 87 megabytes uncompressed. I think what we'll do, if we SSH into our Raspberry Pi again, we will docker pull Ubuntu Jammy. So this should pull the ARM64 version of their image onto this machine, and now we can get some appreciation for its size. So Docker images here tells us that their Docker container is 69 megabytes. So we need to try and shave some stuff off our build process. So I think we need to get close to that before we start generating Docker images. So let's head back here. What did I break here? Oh, here it is. Here's the bug. So we'll do that. Let's fix that. Why I couldn't find where my stuff was. And what we'll do is down here, after we've done that piece, we will do a du -csh and the root file system. So at the end of this, each time, we'll see how big our root file system is. And that should hopefully help us track our progress. So we're heading towards, initially, we want to get close to 75 meg, I suppose, which will get us moving in the right direction. So if we take a look at our bootstrapper here, let's have a look up here. I had all of these exclusions, so we're going to just try our luck with how many of these can we just cram into this thing and see if it works. So I'll just explain what these are. This is internationalization, so translations for debconf, a thing that configures deb packages which we don't need. DM setup, our justification was you really don't need that on a Raspberry Pi, given that it doesn't have sophisticated storage controllers. No eject, because it's a Raspberry Pi, and who's plugging CDs into a Raspberry Pi? No info because there are man pages, and maybe we can do something about the man pages. No netcat, because again, this is for computers, not people. Now, the Ubuntu minimal meta package I don't think is being installed because we're using this variant min base, but we'll leave these in regardless. So we will do that and save that and run it again and see if that makes any difference, any appreciable difference whatsoever. So let's leave our actual Raspberry Pi and rerun the build. So whilst the build's running, has anyone downloaded these images and actually been able to put them on a Pi and boot a Raspberry Pi off them? I know you haven't, Big Pod, because I've still got a box here with your name on it.
I actually wanted to pull it onto at least the one at the end, pull the image onto a AWS host, but I figured out that the two-factor key is on my phone, which is used as a camera.
Oh, I see. Oopsie. So I'm just looking here, whilst that's building, I'm just looking here at the packages that it's installing to see if I can see anything here that I think we can drop. Now remember, some of these packages will be installed because they are dependencies of core components. So we haven't got a lot of wiggle room here, particularly when it comes to libraries. I'm not seeing anything that that stands out. Yeah, that's quite trim. There's not a lot. There's not a lot in there to remove. I don't think. I don't think this is going to be a whole lot smaller, if any smaller.
Yeah.
I mean, I can probably not do this. I don't need that in there.
Yeah.
So we can get rid of that.
And maybe possibly getting rid of one of the shells, even though those are pretty small.
Yeah, we could. Well, so I was thinking about this earlier. We absolutely could say don't install the shell. The issue here is that the tiny shell is Dash, and that's POSIX compliant, but it isn't compliant with the Born Again shell. So if anyone is using like scripts to deploy in their containers, it could like break their deployments unexpectedly. So but this we definitely don't need, right? That seems entirely unnecessary. So we'll just grab that and we'll add that to our list here, so we can have another go round in a moment with that removed. Also, that did have some vulnerabilities in it recently, so that would mean that, you know, it would remove some vulnerabilities from the container too.
I actually remember me asking you, why do we need a library or program to mess with the file system in a container?
Yeah, it's like, like you say, if it's in the container, do we need any of this stuff? I mean, do we need gzip? Possibly. I mean,
probably some people pull in stuff like stuff. Actually, what it was a couple of weeks ago, I was making a new base image for Node for someone, and I did it all in a Ubuntu container.
Right.
So I just pulled in a latest node from their website and unpacked it into the right directory, and that was it.
Nice. So you were saying remove password, right? We could. If you don't think it's necessary, I mean, I'd be interested to see how that breaks things in new and interesting ways. I can make a case for all of these other things here. Debconf we totally need, and debconf is what's pulling in diff utils. So a whole bunch of core libraries.
Maybe grep, but grep is used in all the other fun ways by the everything else in the image. So let's not break everything.
I was going to say, it's like there are certain expectations of what scripts need rather than what people need.
Yeah.
I mean, I'd love to get rid of Perl base, but you can't, because so much of the Debian packaging ecosystem relies on it. So I think we've probably identified the only reasonable thing we can remove, which is E2FS utils. Anyway, I mean, we could remove, apt and dpkg. So actually, that didn't bring the size down appreciably. That's still 87 meg. So let's move on to where were we? We were going to rerun it again. Now we've added that to the mix and see if this improves anything. So it doesn't actually take that long to run, and certainly now the caches are warmed up, we'll just let this go. It should probably take maybe a minute to do everything it needs to do. So let's just see. Can we see E2FS utils in here? No, it's definitely gone. So the only thing I would say is, even if that doesn't move the needle in terms of the file, the file size of the image, I definitely know it's more secure now. I am tempted with your idea of dropping bash. Like, I bet that doesn't. It's not actually big enough to warrant such a change. Let's see how big bash is after this has run round. So, right. Oh, well, there we go. We've saved 1 megabyte by doing that.
Probably not whole megabyte.
A whole megabyte. It all counts. Yeah, look at this. So the download size for bash is 800k. So installed size 2 meg nearly. I tell you what, well, we got ruthless with the other one. Should we do it anyway, just for giggles? Maybe not. Let's, if we get desperate. So I think what we'll do now is we clearly need to find a lot more stuff to remove. And I've got an idea what to do, but I don't know. I mean, I'm, like I said, Canonical have a whole team who do this.
Yeah.
And trying to reproduce it in maybe a couple of hours might be a bit of a tall order. But if we go here, we're going to look at a project that I used to work on, which uses another container technology. And I added some bits to this to trim out some stuff that we don't need. So we'll go and take a look at this, see if we can borrow something from it. So this is the Snapcrafters community repository, and I used to maintain the OBS Studio Snap, which is hefty. But one of the things I did, which wasn't so much to bring the size of this, you can effectively call it a container, to bring the size down.
Well, it is a container.
It is, yeah, it is a container. Was I did this. Warcraft in. And this hoovers out a bunch of stuff that you don't need in a snap, which is, like BigPod says, just a container. So it removes a bunch of stuff, and this was about reducing the number of files in the snap so that it started faster. But I think there's some of this we can probably borrow from, so we'll give this a go. We'll drop that in just here and then tweak it a little bit and see what we've got here. So Craft is legit. We just need to change everything here that is about Snapcraft to, we need to do this. Probably pull these back to start with. Like so. There we go. So a lot of that we're not going to need, but okay, let's start thinking. So then we do RM, and instead of Snapcraft Prime here, we want to replace that with rootfs, which is our variable for where our root file system is that we're working on.
Yeah.
So we'll do that. And oh look, this is gonna just delete all the man pages. That's a bit unceremonious. I'm pretty sure that Canonical system doesn't do that. Now there shouldn't be any icons in our thing because it's really minimal. So I'm just gonna remove that because I don't think that even needs to be considered. And I don't think gcomp even needs to be considered either, but we'll leave it alone for now. So what this does, this is effectively something I developed for a nameless corporation. I say nameless corporation as in I am not going to name who it was. And what this does is it prunes the documents directory.
Right click on, when you select, right click on it and it will all the selections.
Oh,
right click
I'm
and,
getting, what do I do? Paste.
No, you have to select it first.
Select
then right
it.
click on the selection.
Then right click on the selection.
And there should be find all references, I believe. This is the correct one. Yeah, I think so. Change all occurrences.
There it is.
Change
Find
all occurrences.
Oh, change all
Another one.
occurrences. Oh,
Yeah.
what have I just done?
I think you should be just able to go on and select the files again.
What have I opened over here? Like,
On the left side, just
change all occurrences.
now paste.
Oh, that's a great skill. Thank you for the lesson.
Now click on your left side where you have those two files and a number one icon.
Those two files and the number one icon there.
And it's gone.
There we go. Nice. Thank you. Right, that was some good learning there. I like that. Right, let's put double quotes around this. Let's do the same here because our root file system could be being built in somebody's home directory that is got spaces in the username because apparently that's a thing.
Really? Didn't know that.
Yeah, it really is.
That's something new.
Or with like, you know, Unicode characters and things like that, which is probably, well, in fact, I'm talking to somebody who has Unicode character in their actual name, and some people, you know, put that in. So we'll
I tend to not put anything like that in my usernames, stuff like that, because I do know most people on the board don't have those characters, so
Yeah.
just not put them.
Yeah, well, you're very thoughtful. But there we go. Okay, so here we go. So this is going to remove any empty directories, which is fine. There shouldn't be any. This is going to remove all of the readmes from the docs. This is going to remove all the examples from the docs folder. This is going to remove, there's always things like an examples.gz file in the document somewhere. That's going to get thrown away. And then we're going to delete all of the files, start by deleting all of the files that we can call that are not the copyright files. So that what we're going to preserve here is all the copyright files for the packages that have been installed inside this image, so that we're good, respectful, open source citizens. So this is our big change. Delete all of this stuff. Why is this telling me there's a problem? Oh no, it's fine. I'm just going to ignore that. You should do something about that, but I'm feeling confident or lucky. Famous last words. If the stream goes off, I've just deleted my root file system.
Yeah. Well, then you have a reason to install NixOS or Fedora.
This is true. This is true. So we'll run this process again. Yes, Eric. Oh, indeed. And I do say that not with a tongue in cheek, because I have done it. I've even done the inverse, which is deposit an ARM operating system over the top of my root file system, and getting that to boot afterwards was a challenge indeed. So yes, it's a rather brilliant foot gun if you don't manipulate this with care.
Yeah.
Right, what are your predictions?
I managed to never delete my file system with DD, so that was a big thing for me.
Oh, I've done that a long time ago. Definitely done that. Yeah, I've written the wrong device with a DD and completely wiped out a hard disk entirely. Yep, done. Been there. Got
One
that
time
t-shirt.
I was so close to doing it, but then I checked one last time and managed to not screw the laptop with my whole school year on it.
Right.
Directly in the class. That would have been not fun.
So, hey, Destro Camille, let me just bring up your question here. So, Oh man, feature chat is being dim. One moment, let me just see if I can get the chat highlighter to work whilst that build is finishing. Let's try this again. Well, I'm afraid my little chat mechanism here is being a bit awkward. So I will answer your question. So Destra Camille asks, how do you create an ISO image from that? So it can be done. I have an example of how that can be done in another project. In fact, we can look at it in the context of this project, but we will look at that in just a moment, Destro. So BigPod, I think it was 86 megabytes last time. Do you want to give me a prediction? What do you think we've got it down to?
75.
75. I'd be happy with that, I think. So let's take a look. 78. Okay. That's not too shabby. I'll take that. So 78 megabytes. I feel like, so we technically we should try and find another 10 megabytes. I wonder how Canonical do this, because I can't think of what else we could get rid of. Let's just take a look at Destro's question. So we will go and look in my code editor. So at the moment, Destro, we're making base images today. A few streams back, we made a host operating system for the Raspberry Pi. So we had to make an image, like not an ISO image, but we had to make an image that you put on the USB or SD card in order to boot the thing. So in the project, there is this script. So actually, if we go and look at this on GitHub, because then you can see where we're getting this from, and you can go and look at this for yourself. So the project is here. I will just stick this in the chat for you. And the script here that says SlimEOS image makes an image for the Raspberry Pi. Not an ISO image, but I'll get to that in just a moment. So there are various stages in the build process, one of which is this one here, stage 6 image. So how that works is like this, and you can use similar techniques to make ISO images. So here it is. So we have our directory, which is a root file system at this point. Now, these Raspberry Pi images effectively have two directories you have to overlay mount, one for the firmware, the Raspberry Pi bootloader, and one for the root file system. So, but this is not that different on an x86 PC, where you need to account for things like EFI partitions these days. So what we do here is we set some variables to define the size of our boot partition. So you could think of boot as your EFI partition in PC speak, and the root partition. And then we calculate some sizes here. This rather exotic calculation in PureShell works out the size of the file system plus exactly 5%. So the resulting image that gets created is predictably and precisely 5% larger than the actual volume of files that it needs to accommodate. So we then create a sparse file with fallocate here, and then we manipulate that file with partitioning tools to create partitions in the usual way you would partition stuff. It's, we're just treating it like a block device at this point. And once we've, created all of our partitions and, formatted them, well, not formatted them yet, but allocated them in the appropriate way, we then loop back mount them, and then we make these file systems over the boot loop back and the root loop back. And then we rsync our root file system and our boot file system over those loopback mount things, and then unmount them. And now what you have on your hard disk is an image file which has all your stuff in it. Now what you could do is, instead of simply doing this, you could use at this point like something like XorISO to make like a bootable ISO image if you were doing this for PC. So, you know, read the man page for XorISO and, you know, take this and replace bits with it. But that's effectively how it's done. Hopefully that is a close enough answer to the question you're asking here. Yeah, it's not. No, as Big Pod says, it's not that different. The structure of these images, it's got the same stuff in it. It's just that, you know, bootable ISO images have some different partitions in them to make them bootable and stuff like that. But XorISO can create all of those. And I do have another project where I think I've got examples of how to use XorISO. That's a bad example, actually. I won't show it because it's actually got a squashfs file system for the ISO. So I won't show that because it's a bit different from this. But hopefully you get the idea. Bill says, I'm going to try and use this tool. Yeah, there we go. Don't you have a tool to compare base images to diff and look for clues? We do, because we are Slim.AI and we are armed to the teeth with all sorts of cool stuff. However, I want to get close just by sort of eyeballing it before we get into sort of a more detailed analysis. But yeah, we've got tools to do this, and I'll also let you into a little secret. One of the reasons I'm doing it eyeball style at the moment is I'm not sure I know how to push one of these architecture Docker images to Docker Hub so we can start looking at it. I think I know. You do? Good. Then we may be able to.
There is a command for that.
Okay.
It's called Docker push.
Oh no, that's a different issue. I'll get to it. I'll show you what I
know. It should work.
Okay, I'll show you what I don't know in a bit. If you have an
ARM only image,
okay, but
it's a lot harder process if you have an image that is ARM and x86 at the same time. That's a process. But if you have one architecture only, as far as I know, it's a simple process. But don't hold me on that. That's what I've seen. I don't have much about ARM images because I have no ARM devices besides my phone.
Right. Well, so Destro, I'm glad that was helpful. And if that's pointed you in the right direction, that's great. And if you've got follow-on questions, hop into our Discord. You'll find the links at the URL above my head, Slim.AI. I'm Wimpy, and Primoz goes by Big Pod. Just ask in there and we'll be happy to answer any questions you've got. So, yeah, I thought it was going to be easier, but I ran out of knowledge, so we'll get to that in a little bit. So where were we? We've got it down in size. So I think what we'll do is we'll take this and we'll see how it compares, because as Phil points out, we should probably I did have one idea, which was this. What if I hop in here? Oops, into the root file system. Here it is. If
Can you please open a user share directory for me?
Well, I can do that. What I was going to start with is seeing the relative size.
Yeah,
of
that's why.
Each of the
73 megabytes there.
Yeah.
That's why I asked. I want to see, because I think there might be some stuff there to delete.
Hang on a minute. It didn't. Yeah, 73 megabytes. So let's do this again. Let's go down and find out. So it's in lib and share.
Yeah,
so lib has got 43. That's fair enough. So
but
9 in share.
Not what we can remove, but share has a lot.
Okay. Let's have a look. Where is it all hiding? 6.4 meg in local. Ooh, we could get ruthless in here, couldn't we?
Doc has 1.3 megs.
Still got 1.3. Okay. So,
And while not a lot, but
not a lot. Let's
also
start
not useful, is bash completion at 340k, which is a third of a megabyte.
So let's just see here. We could get rid of this whole directory. We could do what we did on the host OS. We could trash this entire directory and set the locale of the system to just use the C, locale.
Yeah.
The
I say all you need to leave is that SL locale so that only I can read it then.
Oh no, if they're all going, they're all going. we're not gonna play favorites.
so that 2 million people at best can read it. That's how many there are of us. So not many.
Okay. So shall we do that? Shall we let's just pick an example. Let's see here. What have we got? Let's do Spanish because I can cope with that. So I have got Tree on my local system. So it's only for apt, dpkg, and core utils. Okay. I think we get rid of this. I think we just trash this directory. There's not enough translations in there to be useful.
Yeah, makes sense to trash this.
Right then. We'll add that to the purge list then. User share locale. Let's just ruthlessly axe that whole thing and hope that it doesn't cause any problems. Here we go. We'll just take that line there. We'll add user share locale. And right then. And you said there was a few things left in doc, which there should be, because we were trying to preserve the copyright files. But we could get a sense of that by going in here. Is it anything other than the copyright files?
There is a link. So
that's a sim link, so that's fine. That's a 0. So I think it is just the... Oh, here we go.
There is a base
well.
file. Yeah, but it's some README files, so...
So the only thing we could do, maybe, is iterate over every single copyright file and gzip them.
Yeah.
Because at least they're preserved. That maybe will save us... Well, it will save us most of that. How big was it?
1.3 megs.
Yeah, it will save us comfortably a meg, I reckon. Doc 1.3. Yeah, I think that will save us a meg comfortably. There's nothing else dangling out here, is there?
Well,
there's the libraries, but I don't think there's going to be anything there we can really.
Yeah, maybe that half a meg in info might be worth removing.
Yes, we could trash that because we haven't installed the info tool. So yeah, we can totally get rid of that.
And
okay,
maybe throwing away
ideas.
bash completions might be useful.
Well, maybe.
It's third of a meg.
Where was that? That was in user share bash completions.
Yeah.
Okay. That seems a reasonable thing to get rid of. And what was the other thing you said? Info. So are these info files? They are. Yeah, so we'll get rid of those as well. Because we don't have an info tool, I don't think, in the image. We look here, there should be no info. I see
Not
ID
that I can see.
info CMP. I'm not even sure what that tool is. This is obviously I'm on my term info. Okay, fine. Right then. I think then we'll get rid of the info directory and bash completions. So yeah, this is how to, you know, undo the hard work of package maintainers everywhere, basically. Where am I? I'm in the wrong place. I want to be in user share. User share. So bash completion and info. Everything else we think is fine, don't we? GDB, actually, what's in there? Oh, fine. That's fine.
17
Right.
bytes.
Info locale GDB. Okay, let's go and get rid of those things then. Not GDB. Bash completions. That was the first thing. Is it completion or completions?
Without an S.
Without an S, thank you. And info, right? That was the other one we were going to get rid of.
Yeah.
Was that it? I think it was, wasn't it?
Yeah.
Okay, let's give that a whirl and see what we get down to.
Now I can say again 75 and we'll be there. 75.
75. That's your target, is it? That's your
Yeah.
Okay.
Well, okay, probably be at 76, but yeah. Close enough.
What does chat reckon? What are we going to get to? Yes, so John says, looks like I'm using Exa. Not Exa, I'm using LSD, which is LS Deluxe. That's what I'm using for LS. And Phil Clifford rightly recognizes that this terminal is indeed a custom cool retro term. This was something I started doing on my own streams a little while ago to make terminal stuff just a little bit more interesting to look at. 55 megabytes, you reckon, our podcast? Well, that's too low.
Way too low.
71. Oh, I think that may be
forgot to
smaller.
account locale.
Yeah.
I forgot
There we
to
go.
account locale.
Let's just
That makes
SSH.
sense. Yeah.
Let's just SSH back into our Raspberry Pi a second. And we do Docker images. We have an ARM64 container. That's 69. So
Yeah.
we're within 2 megabytes here. Okay. I think we'll go with this, right? We're close enough. We'll go with this. And then
Let's call it error of measurement.
well, we don't know until we do what Phil says, which is actually like try and compare it apples to apples.
Yeah.
For all we know, we may have overshot here. So let's see how we go. So the next thing we need to look at is how to take that tarball. So let's just actually go and remind ourselves. We're on the Raspberry Pi again. So in the builds directory, we have this tarball here, and the tarball is 25 megabytes, down from 32, so the compressed thing. That's the tarball of our root file system. So what we need to do now is basically do a from scratch Docker file, which adds that. Phil Clifford, close enough for rock and roll. Yeah, I think I'll take that. So I took another script that I've used in the past, and we've got this. So this is very jank, and this is where I'm not sure if we can proceed much further. So we'll see how we go. So what this does is it basically looks for the tarballs of our base images. It extracts the architecture because I integrated that into the file name. Clever thinking, I thought. We're just going to call the tag latest because we copy the tarball into the current working directory because that's what Docker requires, and then we generate a Docker file. which says from scratch, add the tarball that we've just built and give it a command line entry for invoking bash as it happens. Good job we didn't remove bash. And then this is what I was trying to do. So, and this is literally minutes before the stream came up, I was Googling this, and this is the point at which my knowledge expired, because I've never pushed an ARM container to Docker Hub or any registry before that was built on not the architecture of the intended machine. So
Yeah,
what we'll do is we'll run this script.
It should work.
Okay, so what we're going to do is we're going to run this script and we're going to let this run here and we'll see a problem. So if we just hop back into our shell, we will go to examples, and this is for base, and we've got this build script. So we'll just run this, and there we go. It only takes a moment, but here we go. Look, that line that reps the architecture of the container. Oh, that's the right answer.
Yeah. Again, I'm gonna say I don't do ARM, but I think this worked.
Okay.
So...
Okay. I maybe my bad eyes read that as AMD 64 earlier, because I started researching how to use this Docker buildx thing. So actually,
buildx is useful if you want to do
cross compile or
that
something.
does both AMD 64 and ARM 64.
Okay. Oh, so it's multi-architecture containers. Yeah. Okay.
Single image.
Okay.
So it's basically what it does. It's called Docker manifest.
Okay, I'm surprised. I'm surprised this has worked. So it has built the thing. I think this may not work for ARM32, but we'll come back to that in a bit. We'll figure that out.
Yeah.
We tag it with latest. We try and coerce the architecture. Everywhere I read that architecture could be coerced, and that must have worked, because when we looked at it's the same image, isn't it? It's definitely the same image name. Yeah, Slim.AI base tag. Okay.
I'll push it, and the only good test is you need to push it and then pull it on your Raspberry Pi. That's the only test I know of.
That's what we're going to have to do. So I will add those steps to this build process and do that very thing. So here it goes. Ooh, that said 67 megabytes. Did you see that?
Yeah.
That said 67.
It said 69, but
nice. I think we're in the right ballpark here. Okay, so that has pushed something up to Docker Hub. So let's go and look at it on Docker Hub, because I'm not sure this is actually going to tell us anything useful. Oh, I'm not logged into Docker Hub, am I?
I don't know.
No, I don't think I am. Not here, because yeah. Okay, so I may just have to drag this.
Try just going there without being logged in.
Hang on a second. I'm just having a little bit of driver difficulty. Have I logged in here? I have. Here we go. Here it is. So, Slim.AI base. How does this tell us the architecture of the thing anywhere?
No. Try tags.
Tags. Yes.
And
OS architecture. Holy cow. We've only bloomin' done it. Okay, right then. So, I'm feeling good about this.
Docker pull.
Let's go to the Raspberry Pi and pull this thing. So, Docker pull Wimpress. What did I call it? Where is it? Still up here.
Base.
There we go. Slim.AI base.
Slim.AI base.
And I think I called it latest, right? So
yes. But it's uncompressed.
Okay.
Now Docker run.
Oh, well, hang on. All right, let's see how big it is first.
And I think we're already there.
Oh, get
it did
in.
fall.
Check that out. Okay, we're totally... Does it work? So, Docker run.
It should work. I'm gonna be honest.
Hang on a minute. What do I need to run?
WinPress / Slim.AI -base. Before that, you need to put in -it.
Yeah.
Before the image name.
Yeah.
Otherwise, it throws a hissy fit.
Okay. Bash.
No bash.
Not.
Go back.
Go
Just
on.
go up and add entry point before the image name. Image name must be last.
Like
Docker.
so?
Entry point, space, sh, space, without equals.
Like that?
Yes. Then you must have equals. I don't know. Oh, 2 dashes, of course.
There we are. We're in.
There you go. You have a shell.
Oh gosh, it's not human friendly.
It's shell. It's the most basic shell you can get. POSIX compliant, most basic shell you can get in Linux.
There we go.
That's that.
Right then. So from here we could. There we go.
Bash.
Now we've got something we can actually use. There we go. We are in business. This is. I'm absolutely shocked. I didn't think we were going to get here. So, Defo Jammy. Yes. Yeah, I think Cypheric. Yeah, we're riding our luck, big style there. Absolutely, beyond a shadow of a doubt. But also, only managed to make it smaller, didn't we? Tell you what, that's pretty good, and it in air quotes works, right? So
yes,
let's go and use our tools to compare this image that we've just pushed up to Docker Hub against the Ubuntu Jammy one, and do as Phil said. Let's work out now. Now we know it's smaller, but we can go and see why it's smaller. But more importantly, is there anything missing in the official Ubuntu container that we haven't yanked out that we could go back and add to our brutalization of this container image to make it smaller still? So
yes,
let's go and try that. I'm very happy with this, though. I have to say, I am very happy indeed. We could, these Slim.AI OS base images, we could bang those out for a whole bunch of architectures as well. So that would be fun. Once we've got this template down, we could just iterate over all the architecture names. So we're going to Slim.AI.
But if you're going to go for a widest approach, then you do a build X and Docker manifest, and you have one image for everything, and then Docker client actually takes care of downloading the right one.
Right.
But I'm not that good at Docker manifest because I never needed one, as I only have x86.
Yes, like I say, I've never got into this multi-architecture stuff before, in this way. So Slim.AI base, right? Here it is, should appear. So let's use our tools to take a look at it. Updated
Most
6 minutes
people
ago.
tend to use multi-architecture images because of two things: Mac, and because of the what is called the Graviton on an AVS.
Oh, hello.
There appears to be something wrong. Try to go back.
Yeah, that's not right, is it?
Try again. .ai base.
Yeah, I was going to say I need to get that in my head.
And just click analyze button.
Let's click that button there. Here we go. This is more like it. Right then. So this is going to be a single layer image because it's a base image. So there's going to be nothing useful we can look at from the file system view because we kind of know what's in it because we composed the thing. So, oh, okay, that's interesting. That's been changed to SH. We should look into that.
Yeah.
But okay, let's have a look at the overview here. So here we go. The architecture's reported. So this is good. Uncompressed size 68 megabytes. Okay.
It rounds up.
Okay, that's fine, but that's fine because then
The difference would be 2 megabytes because that also rounds up as far as I remember.
Wasted space 500k. Oh man, we need to do something about that.
We have half a meg too much.
And
all
of these sim links and things. I mean, given that, we need to leave bash in there, I think. Oh, these things, okay, fair enough. Is there anything here we could potentially get rid of? Probably not.
Possibly no, nothing.
I mean, SU maybe. Right, so this is all interesting stuff. Let's go and do a comparison. This is where we'll learn something. So we're going to compare our image. Let's do our image because ours is smaller, we think.
This.
I need to change that.
Yeah, it's already selected. There is already selected. This one. Yeah, this one. Library/Ubuntu is the right one. The base Docker Hub address, the one that is just without anything in front of the name, is called officially library. Yeah, it's the same problem. Reload this page and then you need to change the first one.
Yeah, that was not responding.
The first one. Change the first one, the Slim.AI base. Change that one to Ubuntu.
What do you mean? Oh, make this one Ubuntu. Oh, okay.
Yes. Then you can swap them around.
Of course. Yes. That's...
The same reason why, because of the same reason they didn't show up, the latest didn't show up there. Yeah. For some reason.
Okay. So we'll then flip the order like so. Yeah, I should get and have... It's right there, and I don't do it that way. Right then, let's do a comparison. So, do you think there's going to be anything removed from the Ubuntu container that we haven't removed?
Probably they are the experts on Ubuntu containers. So
without a doubt.
They deleted something we didn't.
So, we have. In fact, let's do this first of all to start with. So let's just get. Wow! Actually, we've exceeded expectations here. Look, our uncompressed size is 68.
One problem.
Yeah,
go on. one row lower.
One row lower.
Below uncompressed size, it's OS architecture.
That's interesting. How do we do that?
That's, I think, gonna be hard to solve.
Okay. Well, this is feedback for the.
I have one trick to do. One trick might work.
Okay, go on then.
Pulling the image on Raspberry Pi and pushing it to your Docker Hub.
Yep. Okay, that'll do it. That's a way to work around it. The other. Oh no, I was going to say using Docker Desktop and our extension, but that Docker Desktop isn't available for ARM. So let's do your idea. Let's do.
I guess we should tell our coworkers that this needs to work.
Something we need to think about, like how do we solve that one? Choosing the architecture. Yeah, for sure. I wonder if any of them are watching. Right, sure. Let's do Docker images. We'll do Docker. Let's just at my... Oh no, this is the wrong place. I can't remember the syntax. Just one moment. Tag the thing with the remote name. Okay, so it's Ubuntu. It was Ubuntu Jammy. So I want to call that. Yes. Okay. Back here. Yeah. Okay. Tag Ubuntu Jammy as WinPress Ubuntu Jammy, right?
Yes.
And then Docker push that. Denied requested.
You probably do not have. You're probably not logged in.
Yeah. Oh, I'm not here, am I?
Just type in Docker login.
Yeah.
Maybe you're just logged out.
I know. Well, this is that Raspberry Pi, and I've never logged in.
Oh yeah.
So
yeah,
I will just do that up here. Oh gosh. Okay. One moment.
Also, we might find out that we are just unknowledgeable soon. We'll see. I
just bear with me. I just need to.
I have back channel to the.
Okay.
To the
Are
right people.
You're finding out if we can do this? Is that what you're?
Officially, we do not support any other architecture.
Okay.
Officially. But
there may be ways.
Unofficially, we know you can do ARM64.
Right, okay, I am logged in. And I'll just put some garbage in there. Okay. Right then, so we'll bring that back down here. I'll just move that out of the way over here. And, oops. That was a good workaround. This is why you're here. There we go. So now we're pushing Ubuntu Jammy to my own repo. There it is.
Oh.
So.
And we have someone watching, so.
Okay, okay. So,
there might be a problem.
Should I explain?
I think there might be a problem.
What we go on?
It mounted from library Ubuntu, so it mounted the whole thing. I think. Try, but I think we're gonna get AMD 64.
Oh, okay.
Try, just
okay.
try.
Well, we will. So, for if one of our colleagues is watching, what we've done is we've built our ARM64 container, and we wanted to compare it with Ubuntu to see what we're doing in our container composition to compare with the official Ubuntu images, but we've found that the Ubuntu image, it pulls the AMD 64 image because my container is only ARM64. So what we were trying to do is figure out if we could level up these architectures. So the workaround is to push the Ubuntu image to my own repository, my own registry, and let's see if this works.
Oh, yeah, I think it worked, but there's that we do not support ARM. I think.
Well, it must do in some respect because here it is.
Yes, I think that's the some of it works, some of it doesn't. But
okay.
But you can at least look at that one. Try looking at it. We can see at least the size.
Yeah. Well, we can also.
And if it.
Oh. Well, maybe this is a different problem.
Yes.
I don't even see it in my registry. Oh, there it is.
There it is. Yeah.
Okay. Now,
maybe.
Could we
wait
see?
A minute.
We could see the architecture. Here we go. It is. Yeah, it is ARM64.
But it's slightly different.
It is. It is.
ARM64 V8.
So maybe we could fix this by building our image with that same architecture flag.
No, I don't think so.
Yeah, because I.
No, it's not the architecture flag that's the problem. It's
But they're
the
different.
architecture itself. No, you could do ARM versus AMD 64, not a problem. Its problem is that we do not support ARM 64 or ARM in particular, so it doesn't detect a different.
But we were just looking at an ARM.
Yeah, because
container.
we have latest. Because we have latest.
That should
Latest is automatic, and because it finds latest without a problem, it does, even though it technically doesn't support.
Okay.
ARM
All right
64.
then. I accept this challenge. Let's see what we can do here.
But it won't work to select it for diff.
Right. Docker tag Ubuntu Jammy WinPress Ubuntu latest.
I think this turned out into the same kind of stream we always do.
Yeah, well, we knew it was going to come off the rails eventually, because these challenges always do. But it's the trying to find your way out of the maze that's the interesting bit. Like, so we've just learned something about our own platform as a result of doing this. So, you know, this is feedback we can provide to the team. It might be an edge case. I wonder if this is an edge case. Who's working with ARM-based containers? I mean, it is a significant deployment target these days. Oh, I did that thing again. Yeah.
I think it isn't. The main targets are people who run either new Macs, but that's just for development, and people who run instances in AVS Graviton instances.
Yeah.
But that's, I think, the only cloud provider actually does ARM.
Okay, so it knows it's ARM64. Right then, let's try and compare this then and see what we get. So WinPress Ubuntu so we'll try here WinPress Slim.AI base. Let's see if we can get this to go.
No.
Because
it doesn't detect a version.
You. Okay.
I think there are some guards against going some that isn't officially supported.
Oh, so John, we've built the thing and it works. What we're running into now is we were going to try and use our tools to actually do a comparison, and we found what's the right word? A feature that is not fully capable, I think, is the issue here, because
it's not fully implemented.
We can look at these ARM images, but we can't compare them.
Because we're going against a software guard to know basically destroy everything.
Okay, let's try it like this then. As I am able to do this, let's go and look at Ubuntu. Is that no, that can't be right. Let's just look for Ubuntu. We don't need any trailing names of it. Let's just go and look at actually I could use this one, because it is ARM at least. So let's just look in this one,
and there was no data available, and that's I think it detected it has ARM images or ARM tags and doesn't display those. It just throws them away. That's the problem.
I think you're right. Now, what we could do is, although the size was different when we were comparing the ARM64 against the AMD64 image, the actual file sizes will be different because of the architecture, the actual machine. What we can do is use it to compare the additions and removals, because the means by which those containers are constructed is the same.
But not with this image.
No, not with this one. We can go back and use.
We can just look at this one. To see.
So I'm just curious to see. So we went harvesting around here.
Share.
In share. So let's see. Is there a local directory? Oh, they've left the info directory behind.
And local directory.
And the local
and bash
directory.
completion.
Okay,
I don't
so
know how they got this slow. Honestly, right now I'm a bit baffled.
well, this is what. So we're going to go and find out. And bash completion's there. We obviously got rid of things like bug and a port as well. I got rid of because I knew that wasn't going to be. That's the thing that tracks application crashes and sends back.
Yeah.
The crash reports and stuff. Oh, dictionaries. There's something we could probably get rid of. That's empty.
It's empty.
Okay.
It was empty there. So that's why I didn't mention it, because I think it was either 4 kilobytes or 4 bytes.
We threw out all the man pages and...
Yes. They have done some magic.
No, they have removed the man pages. Oh, I bet these directories exist, but they're empty. Yeah, they are. Look, that's what they've done. Okay, so maybe we need to do something similar to be compatible, which is don't just outright delete them, just delete the content,
be nice,
just
nice
delete the
people.
files inside. Yeah. So we could do that. Oh, and here we go. Let's see. Yeah, these are all empty. Okay. Right. Okay. Good. There are some things that we've learned. So fine. Okay. Let's go and do a comparison now. I think we know what we're going to find, but I need to do the comparison based on starting with my image.
Yes. Base.
And then comparing it with an AMD 64 Ubuntu image.
Yes.
Which is going to be over here.
On the first one, not the second one. No. Close this. Go to the first box, selection box.
You want me to do Ubuntu here, do you?
Yes. Otherwise you won't. Otherwise you will have to start over.
Oh, okay. Not that one. This one.
That one.
And not latest, but
I think they're both the same.
Jammy.
I think Jammy and latest are the same, if I remember.
No, latest at the moment will be Kinetic. Oh no, it won't. You're right, actually.
No,
sorry, I do apologize.
Kinetic has its own flag because it's or its own tag because it's still development.
So we've got modifications, deletions, and additions. So there are
will be. I think there's some changes in times. So this is.
Here we go.
Time will be different.
In a flat view, if we just look at the additions, well, this is not.
We based it on the first one.
Was Ubuntu, of course, it's going to be all the library paths are going to be different because the architecture triplet is going to be different. So actually, this is going to be real hard to do. So let's try and compare.
And I have so much problem with how architecture is defined in general in Linux, but especially for ARM. You can find it as AR64, ARM64, and then for every version of ARM64 you have a /v something.
Right. So in user share, it's telling us there are no differences, which I'm not sure I believe that.
I don't believe either. Try just deleting the search term and going through the tree by hand. Currently it's in the tree. Good job.
Hang on a minute, where are we? I don't know where we're browsing from at this point.
Yeah. I think we try going just 3, not flat.
Yes, that's what I did. You're right. So let's get rid of that, and we'll go hunting for user share.
Okay.
So. It's interesting that these are
the
this is fine. This is fine. Source, but how is that different between the two? Because
I think one includes the directory, other doesn't.
Okay,
so we removed bash completion.
We removed this, and this. I think I removed that as well. Doc.
Yeah, everything that is red we removed.
So is this the same? Ah,
Yeah.
okay, so it looks like, yeah, all of this has been removed. So it looks like they're doing what we're doing. So we need to do the same kind of approach to the pruning
Yeah.
in those other places where we just outright removed things. So we threw that away. We threw this away.
We
Local
throw the
as well.
directories away, not
Yeah,
files
yeah.
inside of directories.
And term info, I think was missing because we actually prevented the info package from being installed. So
Yeah.
that all makes sense, and this is all architecture specific. But what's interesting is include. So
I
oh
think
yeah,
this is just
I
a
know why.
directory.
The reason why these aren't here is one of the things in my craft cleanup is go and search for empty directories and remove all of the empty directories. So maybe for consistency, I shouldn't do that. In fact, we know we don't want to do that because of the way this pruning happens. So I think I'll remove that because it's not actually going to save any space.
Yeah.
But it may cause problems. So
Technically, it saves a tiny bit of space, but it's so small it doesn't really matter.
So, okay, what we'll do then is we'll just go back to our script and change it to behave slightly differently in the mop-up here. So we have an example of using... Oh, that's the wrong script entirely. We have these cleanups, which I'm inclined to leave, but local... Maybe we'll do this. Instead of deleting these things here, we'll do something like that in each of these directories. Although some of them I really want to remove outright, but we'll do that. So we could add doc in here as well. And then we can have a uniform find remove line like so. There we go. So that will remove all of the files in all of those places, leave the empty directories behind, which we now will not delete, like so. There we go. That's our new revised cleanup based on what we think should work. Let's think about this. This is going to leave symlinks behind, which is correct because that's what I think we were seeing in those Ubuntu images. So let's rebuild our root file system. And then we'll quickly rebuild our container and push it up. And then compare in the same way, because all we're interested then is the file addition removals. I don't need to remove the doc files twice. I've just been told by Phil. So I don't think I am. We're
Yes, you are. You in the for loop. You're also removing it.
Yeah, but that's a different removal. From
Ali
memory.
just said that they remove everything but user share doc /star/ copyright.
Yeah, that's what this is setting out to achieve. Right, where were we? Let's build that again. I've forgotten what I'm doing now. This one. Right. Okay. So this has the potential for being slightly bigger, although should still be smaller because we can see we were being a bit more aggressive with the directories we were targeting for mopping up. So, and yeah, I wonder if we could, E2FS, we know for sure E2FS progs or utils or whichever package it was, we know for sure and for certain that that is going to be in the Ubuntu base image and it's not in ours. So we should have precisely a 1 megabyte advantage at all times. Hey Ali, thanks for stopping by. How are you doing? So it didn't find gconf comps. So let's go and remove those, because if they're not in there, then there's no point, right? Gconf fonts, and what was the other one? PKG config. Yeah, that seems reasonable. There shouldn't be any source packages.
The last one.
Yeah. So let's just save that. I won't rebuild it. It was just for... So we'll go to examples base. We'll rebuild that. And it pushes it as well. This is so convenient.
Yeah.
That is bigger though. Did you see?
Yes, but not much.
So let's go back here. Can I
think just pressing compare should do.
Yeah. It hasn't. Well, let's see.
No, it didn't work because
it hasn't reanalyzed it.
No, not that. It's what's it called? It's cached, I think.
Yeah.
So it maybe rescanning it will work.
That's what I was going to do. Is make sure by
not sure
rescanning it again.
Because I'm not a fan of caches.
45 seconds ago, there it is.
It should work.
Analyze and view this. And then compare it. Oh, I haven't done the analyze stage. Whoopsie. Let's actually let that complete. So, yeah, okay. Compare this, and I need to do it this way, right? I need to say yes. Ubuntu from hello.
If you don't want to find it, just try library/Ubuntu. That just find the right one. First, library/Ubuntu.
Oh, I didn't move the cursor back. Oh, hello. What's going on here? Ah, keyboard shortcut doesn't operate in.
There we go. There it is.
There's the one we want.
Because there needs to be the namespace name for, even if it's just Ubuntu, so they added a library to it. That's how they define it.
Right then, let's get rid of that and go and look for user. Now this is interesting. So these are expected differences because of the architecture difference, but this is saying it's now the same, right?
No, this share.
Yeah. But look, it's saying there are no differences between what is in the Ubuntu container and what is in our container. So that is terrific. So we have happened upon, I tell you what, I'm just going to say, I used to work at Canonical. And that little mop-up script, this thing here, this got shared around the place. And I'm wondering, because we copied some old code of mine, and it turns out it's almost identical to what's in the what's in the container images. So I'm going to suggest that maybe this is like what's the word? It's like shared knowledge that drifts around inside an organization. That I think that it is it's surprising, but when you think about it, not so surprising that. What's this? Is that there's one that's different somewhere.
Yeah, it's just some file. I don't think it was. I don't think it was even in the original.
It's not going to make a huge
Uh,
difference. So
one we were creating.
now if I just go back to and log into our Raspberry Pi, Slim.AI base latest. We'll just grab the latest version of this, and now we'll be able to compare the size here to see how similar they are
Yeah.
here.
No, we
Same
won't.
Yeah, we will. There we go.
Yeah.
So this is what we've added. So we've added, by being less aggressive, we've added 100k to the size of our...
Yeah, and we have we still have few megs of advantage.
So we think that 1 megabyte of that
1.3
is...
megs of advantage.
We think 1 megabyte of that is down to E2FS utils not being in our image.
Yes.
Go
so
us.
now we can't edit file system in the container.
No, well, that's fine.
Oh, so, I'm so sad now.
There we go. So Ali has got a suggestion. Let's have a little look here. Rather than deleting files manually, I use dpkg excludes.conf. It allows you to exclude a path and then override it with more specific include path. Yes, you can do that, and that is an excellent idea. However, we don't have access to that facility. So I think you joined the stream a little bit later on, but the way that we're composing the image is with Devbootstrap here. So we don't have the means to coerce dpkg's behavior in that way here, which is why we're axing the resulting root file system. But I'm pretty happy. Oh, you're using multi-strap. Okay. Yeah, I've read about that. I've never used it. I wonder, yeah, maybe that's something, an investigation for another day. Right then, okay. So if that works, let's do this. Let's change ARM64 to ARMHF. Drop into our local machine, so out of the Pi, rerun our thing here, and now this is going to build the same thing but ARM32, which will be smaller by virtue of the fact that it's ARM32. And let's see if we can build this and push it and it work. Oh no, I can't test. I can't pull it. Can't pull it onto this Pi because this Pi is ARM64. But I should be able to push it and... Yeah, I won't be able to compare it using our tools. I'll have to do the same thing where I compare it with an Ubuntu image. But I wonder what it'll look like on Docker Hub. I wonder if it will know. So look, 59 megabytes. It's a big difference. This is why we, you know, the pointer sizes and everything on the ARM32 devices is why we're getting smaller stuff here. So let's have a think. What can we do now? We can go to examples and base. We can run our build script again, which if we just look at our build script, now that we know this is working, I'm going to remove buildx from in here. And is this going to do the right thing? It gets the architecture. The tag is always going to be the same. This is going to be different each time. Well, let's try. Let's see. It should loop around this twice and push them both. So there's the ARM64 one. Whoa, here we go. Requested image platform does not match the host. Oh, I just ARM, it says here.
Yeah, it's.
Yeah, okay.
Uh, th- th- th-
Where's
it also said that before. It's warning.
this architecture's not correct. This just says ARM though. That's curious.
That might be their internal name for ARM32.
Maybe that makes sense because I've seen weirdly named like packages
It's
built.
ARM. It's weirdly named.
Well, technically it should either be like ARM HF or ARM V7 or something like that. But
Yeah,
what did we end up with?
it's
Does it
ARM.
gives us a smaller file size? I think the only thing I can do is go and look at this in Docker Hub now, right?
Yeah.
And I really don't know if this is going to tell us anything useful.
Well, it might tell us if actually did work. Repositories.
Yeah, I was on the wrong virtual screen. That old chestnut. Right then, so if we go to tags, right?
Yes.
Oh no,
and
we've
Linux
only got
/ARM.
it's busted.
It is Linux /ARM.
Yeah, but it's wrong because look, we've now only got one architecture here.
Yes, that is because it's not a manifest. That's not a problem. It's because it's not a manifest. You don't have both arms.
Okay, so
That's the thing you need to. That's why you would need build-x for
Okay.
so it creates the manifest. As far as I know, if someone else who does actual ARM stuff, please let me know if how wrong I am.
So I think maybe that is like something to look at as a continuation of this, because what I'd like to get to
Yes.
is the place where I can have, in air quotes, the same base image for different architectures,
Yeah.
all visible and
That's
available.
how the Ubuntu image is made.
Right.
It's it has something called Docker manifest, and then it's basically a file that tells this image, this tag is for this architecture, this image tag is for this architecture, and then
Okay.
it's all managed that way. It's weird.
Well, we
Or
will.
this digest, let's be correct. This digest is for this architecture. This digest for this architecture.
We will give that a try. So
Yeah. I think I actually built one today. Not because I wanted to, because I had to.
Right. And Ali says that the biggest space saving that they've found is to throw out all of the Debian based stuff and just go 100% systemd, but then you're not really running Debian or Ubuntu anymore. Yes, and I suppose what you've got at that point, Ali, is more akin to distroless, where you've effectively just got a file system and some bare bones utilities, and then you just drop your stuff on top. Which are you using multi-stage builds from that point? So you've got your sort of really lean base image and then do multi-stage on top of that. Be interested to know more about that. Sounds interesting. Well, okay, we got a lot further than I actually expected. So we need to go and learn about manifests. So maybe that will be a topic for another one of these streams in order to sort of complete this little bit of understanding. But Ali says, yeah, pretty much. And then I compile what I actually need myself. Okay, nice. Thank you for sharing that, Ali. That's an interesting approach. I have played with distroless a little bit recently. It works fine, and you do get small images out the end of that process. I was still able to cut them down but by about 3 times using Docker Slim. So even starting with Alpine or distroless, there's still, capacity to, chop them down even further. But there are lots of interesting techniques out there, and this was really a thought exercise. So I think what we'll do is we'll figure out manifests, and then we'll get to the point where we put some of our own apps inside containers that use our base images, and then we'll run those on our specially adapted Raspberry Pi operating system. Because what I'd like to try and get to is maybe at some point seeing if we can have a stab at beating the world record for the number of web service instances running in containers on a Raspberry Pi. And this is a very elaborate way to try and get there by reducing the size of our host OS and our base images, maybe using a technique like Ali is outlining would take us even further still, in order to see how many containers we can actually fire up on a Raspberry Pi. Ali, if you want to join in that game and take a different path, then that would be fascinating to compare notes. Right, okay, let's move back to this screen. So, have you got any observations on that? Any questions, anyone? Oh, okay, that's nice. So you've preserved the use of apt in your images, so not distroless in that sense. That's nice. I actually missed having apt in distroless. It was a bit of a faff to work with, you know, it's a bit uncomfortable, a bit too uncomfortable.
I miss app everywhere, no matter what I do. Any other images, I will write the whole image with apt install, and then when I actually go and build it,
right.
I figure out it's not actually Debian Ubuntu, and then it's well, let's go and figure out what library names I actually have to use, what package manager it is, and it makes it a whole fun adventure. And at the end, most of the time I just change the first line to be from Ubuntu.
Right. Okay, well, thank you all very much for coming, everyone. Next week, we're going to be looking at some projects that one of our colleagues has been working on. They've been looking at some CI/CD integration stuff with our platform and Docker Slim. So we're going to be taking a look at that. And I think the following week, we will assemble a slightly larger group of people to revisit some of this Raspberry Pi stuff, because we're actually, by doing stupid things like this, we learn things about our own platform. We have learned something today, that there's a slight deficiency and we probably need to get on that. So, you know, there is some method to the madness, in the same way that, you know, when I've worked on other products at other companies in the past, actually coming up with doing some of the stupidest things that you can think of actually unearth bugs and issues in the platforms and the products.
That's what many companies do.
Yeah.
For example, hardware companies, like the companies that make your CPU, what they do is they go ahead and do, or GPUs, and overclock as high as you can, and see if it breaks. That's what they do.
Yeah.
Some of them actually have just that for a job. Overclock as high as you can.
Yeah, well, wait, a long time ago, I can remember when just embedding Unicode in absolutely everything imaginable, every field form and website that you could find, to see what you broke in new and interesting ways. You know, that was one legitimate way testing stuff worked, sort of evolved. Anyway, we'll be back with more of this. If you've got any good ideas, or random ideas, or crazy ideas for challenges for us to undertake with container technologies, do let us know. This is a voyage of discovery. It's not always just, you know, showcasing our own stuff. It's also learning and adapting to new techniques. So if you've got stuff you'd like us to take a look at, or you think would be cool, let us know. Always keen to try out new stuff. But with that, we'll put a bow on it there. Thank you very much for coming, everyone, and look forward to seeing you next week. And we'll be back on Thursday next week at the usual time and date. So see you then.
See you then.
Bye for now.